Okay, so this is the final review, question 18. And for all of these, A through E, we will be using the fundamental theorem of calculus, which states if you take the integral of a function, let's say from A to B, of f of x, is what we'll call that function, that equals f, if we're calling f the integral of f of x, it'll be f of b minus f of a. So that's the fundamental theorem of calculus, and we'll be applying that to each one of these problems. Okay, so this is question 18a, and to solve this right away we can just take the integral of it. So the integral of x is just going to be x squared over 2. That'll be minus, the minus stays, and when we take the integral of 1 over x, we can just think about that as the derivative of what would give us that, and that would be the natural logarithm of x, absolute value of x. And it'd be the absolute value because we're not dealing with complex numbers. So now we write from 1 to e, because it's a definite integral, and we can refer back to our fundamental theorem of calculus. So f of b minus f of a. So in this scenario, our f of b is going to be this e is instead of b. So f of e, and now we plug that into here. So we'll get e squared over 2 minus the natural logarithm of e, absolute value of e. And we can simplify that even further because we know that the natural logarithm of e is just 1. So we'd end up with e squared over 2 minus 1. So that's just f of e. But now we have to find f of 1. So f of 1 equals 1 squared over 2 minus the natural logarithm of the absolute value of 1, which we simplify that. That's just 1 squared, just 1 over 2, so that's just 1/2 minus, and then the natural logarithm of 1 is just 0, so minus 0, which is just 1/2. So now when we go to do f of e minus f of 1, as we can see, that's our f of b minus f of a on top. We can just write them out because we know what both of those equal. And they equal e squared over 2 minus 1, I'm sorry, then all minus 1/2. And we can simplify that if we rewrite this 1 as 2 over 2. That'll make it easier because then we'll just do e squared over 2 minus 3/2. And that is our answer. Okay, so for 18b, we want to notice right away that this on top is a difference of squares. So we can rewrite that to make this a lot easier to integrate. So that'll be x plus 4 times x minus 4 all over x minus 4. And it'll be times dx. And these will cancel out, the x minus 4s. So then we're left with the integral from 1 to 2 of just x plus 4. So now this is pretty easy to solve. So now we just plug in, or not plug in, but we integrate. So the integral of x is just x squared over 2. Integral of 4 is just 4x. And now this is a definite integral, so it's 1 to 2. And we go back to our fundamental theorem of calculus, the f of b minus f of a. In this scenario, our f of b is going to be f of 2. So f of 2 equals, now we plug in 2, so 2 squared over 2 plus 4 times 2. So that's just going to be 4 over 2 plus 8. And that's just going to be 2 plus 8, which is just 10. So now and also in this problem, our f of a is going to be 1, f of 1. So now we plug 1 into that. 1 squared is just 1, so I'll just leave that as 1/2 plus 4 times 1 is just 1. I mean 4, my bad. So this is just 4 and 1/2. And now when we go to do our f of 2 minus f of 1, that gives us 10 minus 4 and 1/2, which equals 5 and 1/2, or 5.5. And that's our answer. Okay, so this is 18C. And this one, we're just going to want to integrate all of these. So if we integrate 3x squared, that's going to give us x cubed over 3. And you'll notice those are going to cancel out, but let's not do that yet. So how we integrate 2x, we have 2x squared over 2, also going to cancel out, but leave it for now, minus 4x plus e to the x, because the derivative or the integral of e to the x is just going to be e to the x. So that's our answer for now. It's not the answer to the question, but now we can simplify. We'll say, okay, these will cancel out. So I'll rewrite that as x cubed plus x squared minus 4x plus e to the x. But now it's a definite integral, so we'll use our fundamental theorem of calculus here. So f of 2 is going to be 2 cubed plus 2 squared minus 4 times 2 plus e squared. So now if we simplify that, that'll just be 8 plus 4 minus 8 plus e squared. And these 8s are just going to cancel out, so you just end up with e squared plus 4 for f of 2. Now when we go to do f of 0, we're going to get 0 plus 0 minus 4 times 0 plus e to the 0, which all, you can ignore everything up until the e to the 0, because the e to the 0 is just going to be 1. So now when we do f of 2 minus f of 0, that is just our e squared plus 4 minus 1, which just gives us e squared plus 3 as our answer. Okay, this is 18D. So for this one, we're going to want to rewrite this to make it simpler when we integrate. So we'll rewrite this as 2 to the x to the negative 4th degree plus x to the 1/2 dx. Because now when we integrate this, it'll be a lot easier. So we'll just get 2 times x to the negative 3 over negative 3 plus x to the 3/2. And I like to just multiply the inverse of that. So I have 2 over 3. Because 3/2, to cancel that out, you just multiply it by 2/3. So that's why I did that. So now, since this is a definite integral, we're going to have to use the fundamental theorem of calculus once again. So now our f of 4 is going to be, actually, I'm going to rewrite this a little bit more. Let's move this x to the bottom right here, and I'll move this negative out in front. So it'll be negative 2 over 3x cubed. This will be easier for plugging stuff in. Okay, so now f of 4 will equal negative 2 over 3 times 4 cubed plus 2 times 4 to the 3/2 over 3, which is just, okay, if we simplify this, this can be negative 2 over, so 4 times 4 is 16, times 4 is 64, so 3 times 64 on the bottom right there, plus 2 times 3, 4 to the 3 halves is just 8. I did that ahead of time, so that's how I knew that right away. But then it'll be over 3. And now what we're going to do is f of, we can simplify this further, but it's kind of a nuisance. And I have the answer ahead of time, so you'll see. So f of 1 equals negative 2 over 3 plus 3 times 1, but obviously it doesn't really matter, plus 2, 1 to the 3 halves over 3, which just equals negative 2/3 plus 2/3. So those just cancel out. So really we're left with this minus 0 up here, so f of 4 minus f of 1 is just f of 4 basically. So this is our answer. And if you simplify this, you actually get 511/96, I think, or was it 93rds? Let me check. 96, yeah. So this is our answer. Okay, so this is question 18E, and for this one, there's no easy way to rewrite it, really, aside from maybe you could use a cosine double angle formula right here, but that would only make things more complicated. So what we should do is just integrate it. So the integral of secant squared of x just turns out to be tangent of x. And that's just because the derivative of tangent of x is secant squared of x, and that's literally what we have right there. So now, and we'll do minus 3, because we know our constants in front of a function just stick there. We don't have to worry about it. But now, when we're trying to solve the integral of cosine of 2x, we can think, okay, what gives you, the derivative of what gives us cosine of 2x? And we think, okay, a sine will come from the cosine, and then the 2x there. But let's see, if we take the derivative of that, so d over dx, that actually be, so you have your cosine of 2x, but then chain rule tells us we take the derivative of the inside of that function and we can put it out in front. Usually is what you do. So, and we notice here there isn't a 2 right there. So to even that out, we divide everything by 2 when we write this, because then the 2's will cancel when you differentiate it. Yeah. Okay, so now we can, let's simplify this even more. So instead of tangent of x, let's rewrite that as sine of x over cosine of x. Okay, then minus 3 sine of 2x over 2. And then it's a definite integral, so that is 0 to pi over 4. Okay, now so our f of pi over 4 is what we're going to solve for right now. So let's draw a unit circle. Let's set it up for us. So pi over 4. So pi over 2 is right here, and this is just 0, 1. And might as well just write this. This is 1, 0. So this is pi over 2, and this is pi over 4 then. And we know that this is just root 2 over 2, root 2 over 2. So the sine of pi over 4, so pi over 4 is right here, sine is the y value, so it's going to be root 2 over 2. And then the cosine is just the other one, but they're the same, so it's just going to be root 2 over 2. And we'll simplify that in a second. But then we have times 3 sine, or I'm not going to actually write the sine, but so 3 times, so 2, when we plug in this pi over 4 into the x, it'll be multiplied by 2. So 2 times pi over 4, we can simplify that to just pi over 2. So pi over 2 is right here again. So the sine of pi over 2, that's the y value, is just 1. So it's 3 times 1 over 2. And now that we'll simplify everything, this is basically just something over itself. So that's just 1 minus 3 halves, which we can also just simplify that as, so 2 over 2 minus 3 over 2, which just gives us negative 1/2. And that's our f of pi over 4. So now when we solve for f of 0, we'll plug in, so what's sine of 0? So 0 is right here. Sine of 0 is the y value, so that's 0, over cosine of 0, that's the x value, that's 1, but either way that's going to be 0, because 0 over anything is just 0. Then minus, we have 3 times, then 2 times 0, which is 0, so sine of 0, again, that's just going to be 0. So 3 times 0 is 0, and then it's going to be over 2, that's 0. Everything about f of 0 is literally just 0. So f of pi over 4 minus f of 0 is literally our negative 1/2 minus 0, which is just negative 1/2, of course. And that's our answer. And that's a good place to stop. Okay, this is question 19. A company determines that the marginal cost, C prime of x, of producing the xth unit of a certain product is given by C prime of x equals x cubed minus 2x. It asks us then to find the total cost function, C, assuming the fixed cost to be 100. So right away, it's telling us that it's asking us to find C, the function of C. So right now it gives us C prime of x. So to go from C prime to just C, we need to take the integral. That's one way to think about it. So first we'll take the integral of x cubed minus 2x. And that's just going to be x to the 4th over 4 minus 2x to the squared, or 2x squared over 2. And then those 2's cancel out. And it'd be plus c, because it's an indefinite integral. And if we look over here, it tells us, this basically is telling us, saying the fixed cost to be 100. The fixed cost basically means when the function has sold 0 amount of products so far, it still is going to be equal to 100. So C of 0 equals 100. So now what we're going to do basically is write that out. Say C of 0, and then we're going to write it into here. But instead of x's, we'll use zeros. So 0 to the 4th power over 4 minus x squared, or not x squared, my bad, that'd be 0 squared, plus c, all equals 100. And since these all are just 0, we just have c equals 100 basically. And now, but it's not asking us to find only c, it's asking us to find the total cost function of c, for c. And so c of x will be basically this right here, but instead of c, it's going to be 100. So x to the 4th over 4 minus x squared plus 100. And that should be our answer. Okay, so for question 20, it asks us to find the area under the curve y equals e to the 2x over the interval 0 to 2. So what we're going to have to do is write an indefinite integral starting from 0 ending at 2 of e to the 2x. And basically, when we integrate this, what we're going to have to do is, we know that there's a formula kind of thing. That's basically whenever you take this is the formula. Whenever you take the integral of e to the ax. In this scenario, the a would be 2. What you'd get is 1 over a times e to the ax plus c. And I like to just write that as the e to the ax over a plus c. So in this scenario, if we just follow that formula, we'll get e to the 2x over 2 plus c. But actually it wouldn't be plus c because this is a definite integral, and this would be for indefinite integrals, the c. Okay, so what we're going to be doing from 0 to 2, now we can, our f, we'll use the fundamental theorem of calculus again, so f of 2 equals e to the 4, because the 2's multiply, over 2, and then our f of 0 equals, the 2 times 0 equals 0, so that's just going to be e to the 0, which is going to be 1, but I'll write that. So basically when we go to apply the fundamental theorem of calculus, so f of 2 minus f of 0, what we'll get is e to the 4th over 2 minus 1/2. So that's our answer for that problem. Okay, this is question 21. It asks, find the area under the curve y equals 4 minus x squared. And to do that, we should note that since it asks for the area under the curve, we can assume that it's bound by the x-axis, or you could say it has an interval, because or else it would have an infinite area. And let's just draw it out to see what's happening. So we see that it's shifted up by 4. So we just do 4 ticks, 1, 2, 3, 4, and it's a downwards opening parabola. So we're trying to find the area of this. But to do that, we need to know where this and this point are, otherwise known as the X-intercepts. And to do that, we need to set this equal to 0. So 0 equals 4 minus x squared. We can note this is a difference of squares. So 0 equals 2 plus x times 2 minus x. So our x-intercepts are x equals -2 and x equals 2. So right now we normally could just take the integral from -2 to 2, because this is -2 and this is 2. We could take the integral from there to there of our function 4 minus x squared dx. But we could just think harder. I mean, think smarter, not harder. And because if we note that this is symmetrical from the y-axis, so if we just find area of one of these sides and multiply it by 2, we'll get the area of both in total. If we call this a1, it's equal to a2. So a1, 2a1 equals a1 plus a2. So what we're going to do is multiply the integral from 0 to 2 by 2. 0 to 2 by 2 for 4 minus x squared dx. So now we'll have 2 times 4x minus x cubed over 3. And then it'll be from the interval 0 to 2. So we'll have f of 2 equal to 4 times 2 minus 2 cubed over 3. What will that equal? I have not incorporated the 2, by the way. So that'd be 8 minus 8 thirds. So now f of 0 will equal 0, well, 4 times 0 minus 0 cubed over 3, which is just going to be 0, obviously. So now we can just multiply 2 by f of 2, because it's just going to be f of 2 minus f of 0 equals 8 minus 8/3 minus the 0. So really, that's why I'm saying it equals f of 2. So it's going to be that, and then we multiply that by 2. And that will give us 16 minus 16/3. So that is our answer. Okay, so for question 22, it asks us to find the area of the region bound by the curve y equals x cubed, and the x-axis over the interval -1 to 2. So firstly, let's just draw this out. It should look something like this. Relatively like that. So let's say this is -1, and this is 1, this is 2. I know it's not to scale really, but so it's saying it wants to find the area under the curves from -1 to 2. So it wants us to find the area from in here and in here. And so the problem with this is normally you'd think, so if this -1, this is 2, this 1. If we try to just do an integral from -1 to 2, it'll take the average of both of these, if you want to say that. But this, since this is going to come out as a negative number, it'll subtract from this area, and really when it should be adding. So what we have to do is split it up into 2 parts. And to do that, we can just do from -1 to 0 and have the absolute value of that plus the integral from 0 to 2. And we don't need an absolute value because we know it's already positive. But if we solve this first one, we'll have x to the 4th over 4 from -1 to 0. So f of 0, which is going to be 0. F of -1 is going to be 1/4. And we know that that's going to be, so really this could be -1/4, but the absolute value makes that 1/4. So then this one, for this one, we'll have x to the 4th over 4 and from 0 to 2. So f of 2 will just be 2 times 2 is 4 times 2 is 8 times 2 is 16. So 16 over 4 minus, then f of 0 will be just 0. So 0 over 4, which is just 0. So 16/4. But now we want to add these two. So we'll get 1/4 plus 16/4, which equals 17/4, which gives us our answer. Okay, so this is question 23, and it asks us to use substitution to evaluate the following integrals. So we'll start with question A, part A. So let's say let u equal x cubed minus 1. So let's find out du, which is the derivative of u. That's just going to be 3x squared minus 0, but just ignore the minus 0. Now we'll write du over dx because we want to write this in terms of du, in terms of u rather than x. So what we'll end up doing is, so du over dx equals 3x squared over 1, because derivative of x is just 1 basically. Then cross multiply, then you get du equals 3x squared dx. But we want to have we want to have we want to get dx alone, so we're gonna divide by 3x squared on both sides, which will give us du over 3x squared equals dx. So now when we go to rewrite this in terms of u, we'll have from 0 to 1 x squared u to the 7th dx, no, not dx, my bad, du over 3x squared. And right away we'll notice these x squares should cancel out, and then we'll bring this 3 out to the front, which is actually 1/3 because it's being divided by 3. So what we're left with is 1/3 times the integral from 0 to 1 of u to the 7th du. And to solve that, we can just do easily do that. 1/3 times u to the 8 over 8. So that's our answer for that part. We need to keep going though. And to do that, we can just multiply this out, honestly, to get u to the 8 over 24. And now let's substitute u back in. So x, we said let u equal x cubed minus 1. So we'll do x cubed minus 1 to the 8th power over 24. And now it's a definite integral from 0 to 1 still. So now we need to find f of 1 is just going to be 1 cubed minus 1 to the power of 8 over 24, which just equals, so that's 1 minus 1, which is 0, to the power of 8, which is still 0, divided by 24, which is still 0. That's 0. That's our f of 1. Now, our f of 2 is going to, or f of 0 is going to be 0 cubed minus 1 to the power of 8, which actually is negative 8 to the power of 8. I mean negative 1 to the power of 8 over 24. So negative 1 to the power of 8 is just 1 over 24. That's what that's going to give us, and that's f of 0. But we can't forget, we need to subtract that from f of 1, which happens to be 0. So 0 minus 1/24 equals negative 1/24. And that's our answer. Okay, so now we're on B. So for this problem, what we're going to substitute for u, you might think maybe e to the x, but since it's the same degree on the top and bottom, what you do is just take the whole bottom and substitute that for u. So let u equal 3 plus 2e to the x, and then find d of u equals the derivative of u is just going to be derivative of 3 is 0, and the derivative of 2e to the x is just 2e to the x, because the constant in front of the function stays the same, and when you take the derivative of e to the x, it's just e to the x. So now we know that du over dx equals 2e to the x over 1, cross multiply, you get du equals 2e to the x dx. Then we divide by both sides, so you get du over 2 2e to the x equals dx. So that's what we're replacing dx with. So we rewrite everything. We'll write e to the x over u, but instead of dx we write du over 2e to the x. And as you see right away, the e to the x's can cancel out, and this 2, or 1/2, can go to the front. So now we have 1/2 multiplied by the integral of 1 over u du. And think, so the derivative of what gives you 1 over u? and that's the natural logarithm. So 1/2 times the natural logarithm, the absolute value of u plus c. And now we're almost at our answer. All we have to do is substitute u back in for 3 plus 2e to the x and add a c. And that's our answer. Sorry I ended up writing crooked. Okay, so for 23c, right away we should see that this is what we should substitute for u, because it's the highest degree and it's binomial. So let u equal 2 minus x to the 4th. Solve for du equals derivative of 2 is 0, derivative of negative x to the 4th is 4x to the 3rd, and then du over dx equals negative 4x cubed over 1, cross multiply, you get du equals negative 4x cubed dx, divide by both sides, you get du over negative 4x cubed equals dx. So that's what we're going to replace it with. And then, so when we rewrite everything in terms of u, we'll have x cubed on top, and then on the bottom we'll have u to the 7th. And then instead of dx, we'll have du over negative 4x cubed. And right away we should notice these x cubes cancel out. So that's great. And we can pull this into the front as a negative 1/4. So right now we'll have negative 1/4 times the integral of 1 over u to the 7th du. But to go even further than that, we can make this much easier by putting to integrate, if we put it on top. So we have u to the negative 7th. Now that'll be much easier to integrate. So now we'll have negative 1/4 multiplied by negative u to the negative 6th over negative 6. And now we can multiply that out. We get the two negatives equal a positive, so it's just u to the negative 6th over 24. And then plus c. But now we need to replace u again with the original so it'll be 2 minus x to the 4th all to the negative 6 over 24 plus c. But now let's move it back into the denominator, and we'll get 24 times 2 minus x to the 4th to the power of 6 plus c over 1. Or I mean under 1. And that should be our answer. Okay, this is problem 23D, and we're looking for what to substitute u for. So right now we can notice, hypothetically, if we substitute x cubed in for u, let's take the derivative of that. So d of u, if it was u, that'd be 3x squared. And what do you know? That's right there. So we know that'll cancel out. So let's do that. Let u equal x cubed. So d of u equals 3x squared. We know we have to do the, we don't have to do this part, but it's just nice to visually represent. And then cross multiply. So we get du equals 3x squared dx. And then if you want to get dx alone, which is what we want, we divide both sides by 3x squared. So we'll end up with du over 3x squared equals dx. So now we're in terms of u's only, so that's nice. So now when we go to write everything back, we'll have 3x squared multiplied by e to the u du over 3x squared. And right away we see these cancel out perfectly. So it's also from 0 to 1, but now we just have e to the u du 0 to 1. And we know that that's just e to the u. That's what that equals from 0 to 1. And then we actually have to unsubstitute that u. So e to the x to the cubed. That'll just, and then it'll be 0 to 1. Then when we plug in 1, so f of 1 is going to equal, I'll just write it out, e to the 1 to the 3. And so when you're doing these, you go 1 to the power of 3 equals just 1. And then e to the power of 1 is just e. So now f of 0 equals e to the 0 to the 3, which is 0 to the power of 3, which is just 0. So, and e to the power of 0 equals 1. So now, when we do f of 1 minus f of 0, we get e minus 1 is our answer. This is question 23e. And right away we see this is squared, so let's try setting that equal to u. So let u equal natural logarithm of x. And then, so du equals 1 over x. And then du over dx equals 1 over x over 1. And so what we're going to get is d of u equals 1 over x. When we cross multiply, 1 over x dx. And then want to get that out of there, we want to multiply both sides by x. So we're actually going to have x du. So when we put it back, that's what equals to dx. So when we put everything back, we'll have u squared over x, then du, and an x here, and these x's cancel out. So what we're left with is u squared du. And when we integrate that, we get u cubed over 3. And now plus c. And then we want to unsubstitute the u. So ln x 3 over 3 plus c. And that's our answer. Okay, this is problem 23f. And for this one, we're trying to find what to substitute u for. And first, we can rewrite this to make it more obvious. We can rewrite this as sine of x over cosine of x squared, like that. And then it should be more obvious, so let's substitute u for cosine of x. So let u equal cosine of x. So du equals negative sine of x. And then du over dx equals negative sine of x over 1. Du equals negative sine of x dx after we cross multiply. That's how I got that. Then you divide both sides by negative sine of x. Get du over negative sine of x equals dx. Sorry for my slanted writing. So now, when we plug that back in, we have sine of x over u squared multiplied by du over negative sine of x. And you can see we can cancel these signs out. We still have this negative, so let's move that negative out in front. So now we're left with negative integral of 1 over u squared du. And from here it's pretty easy. Let's rewrite that as negative integral of u to the negative 2 du. And then that's pretty easy. We just do negative u to the negative 1 over negative 1. That just simplifies to, these cancel out. That just simplifies to 1 over u. Then 1 over u, let's unsubstitute our u, and our u is cosine of x. So 1 over cosine of x equal plus c. That's our answer, but you can also simplify to secant of x plus c.